Right now, at this exact moment, somewhere in the vastness of space, there might be someone just like you. They're sitting in front of a screen, watching their version of YouTube, wondering if they're alone in the universe. They're scrolling through their alien social media, arguing about politics, falling in love, dreaming about the future, worrying about their career. They're living a life that's eerily similar to yours, just somewhere else. Sounds like science fiction, right? But here's the thing that should make you pause. The universe is so incomprehensibly vast that the existence of another civilization like ours isn't just possible. Statistically, it might be inevitable. We're talking about a universe with an estimated 2 trillion galaxies, each containing hundreds of billions of stars, many of which have planets orbiting them. The numbers are so staggering that your brain literally can't process them. And somewhere in that cosmic ocean, the same unlikely series of events that led to you watching this video right now might have happened again. But this isn't just about, are we alone? That question is almost too simple. What we're really asking is, if there's another civilization out there at a similar level of development to ours, what does that mean? What would their world look like? Would they have art, music, mathematics? Would they argue about the same things we do? Would they be making the same mistakes? Would they have figured out things we're still struggling with? And here's the really unsettling part. They might be wondering the exact same things about us right now. 2 civilizations separated by light years of empty space, completely unaware of each other's existence, asking identical questions into the void. Let's explore what happens when we take this possibility seriously. Part 1, The Mathematics of Maybe. Chapter 1, The Drake Equation and Why Numbers Get Weird. Let's start with some math, but don't worry. This is the kind of math that breaks your brain in the best possible way. In 1961, astronomer Frank Drake created an equation to estimate the number of active, communicative extraterrestrial civilizations in our Milky Way galaxy. It's called the Drake equation, and it looks like this: n equals r star times fp times ne times fl times fi times fc times l, where n equals number of civilizations we might be able to communicate with, r star equals rate of star formation in our galaxy, fp equals fraction of those stars that have planets, NDE equals average number of planets that could potentially support life per star with planets. FL equals fraction of planets that actually develop life. FI equals fraction of planets with life, where intelligent life develops. FC equals fraction of civilizations that develop technology to communicate. L equals length of time such civilizations release detectable signals. Now, here's where it gets interesting. We know some of these numbers pretty well now. Thanks to missions like Kepler, we know that most stars have planets. We're getting better at estimating how many of those planets are in the habitable zone, where liquid water could exist. But the other variables? We're basically guessing. We have a sample size of exactly 1, us. It's like trying to understand all of human culture by studying one person in one town. When optimistic scientists plug in optimistic numbers, they get thousands or even millions of civilizations in our galaxy alone. When pessimistic scientists use conservative estimates, they get maybe just us. But here's the twist that keeps scientists up at night. Even if the odds are incredibly, stupendously, mind-bogglingly small, say 1 in a trillion, there are so many galaxies that civilizations like ours should still exist. Lots of them. The universe is so big that even impossibly rare events happen constantly. Chapter 2: The Fermi Paradox, or Where the Hell is Everyone? This brings us to one of the most haunting questions in science, posed by physicist Enrico Fermi over lunch in 1950. After discussing UFOs and faster-than-light travel, Fermi suddenly asked, "Where is everybody?" Think about it. Our galaxy is about 13.6 billion years old. Our solar system is only 4.6 billion years old. That means there was roughly 9 billion years before Earth even existed, where intelligent life could have emerged somewhere else. If a civilization started just a few million years before us, which is nothing on cosmic timescales, they would be so far ahead of us technologically that they should be obvious. They should have colonized the galaxy. We should see their megastructures. We should detect their communications. We should trip over their robot probes everywhere we look, but we don't see anything. The universe appears empty, silent. This is the Fermi Paradox, and it's terrifying for several reasons. Possibility 1: we're actually alone. Life might be so improbably rare that it's only happened once in the observable universe. This would make Earth infinitely precious and also infinitely lonely. Possibility 2: life is common, but intelligent life is rare. Maybe the universe is teeming with bacteria and simple organisms, but the jump to intelligence is monumentally difficult. We might be surrounded by alien moss, but no alien mathematicians. Possibility 3: intelligent life is common, but civilizations destroy themselves. This is the dark possibility. Maybe every civilization reaches a certain technological level and then ends. Nuclear war, climate catastrophe, AI gone wrong, resource depletion, or something we haven't even imagined yet. Maybe the universe is full of ruins. Possibility 4: they're here, but we can't recognize them. Maybe civilizations advance to a point where they're so different from us that we literally can't perceive them, like ants being unable to comprehend the internet. Possibility 5: they're deliberately hiding. Maybe there's a reason advanced civilizations stay quiet. Maybe there's something dangerous about being noticed. Maybe there's a galactic culture of silence that we'll understand only when we're ready to join it. Each of these possibilities has profound implications for what a civilization like ours might be experiencing right now. Chapter 3: The Great Filter. Here's a concept that should keep you awake at night. The Great Filter. The idea is this: somewhere between the emergence of life and becoming a galaxy-spanning civilization, there's a filter, an incredibly difficult step that most potential civilizations never pass. The question is, where is that filter? If it's behind us, maybe the filter was abiogenesis, life from non-life, or the evolution of complex cells, or the development of intelligence. If we've already passed the great filter, that's good news for humanity's future, but bad news for finding aliens. It means we might be alone. If it's ahead of us, this is the nightmare scenario. It means there's something that kills virtually every civilization before they can become spacefaring. Maybe it's nuclear war. Maybe it's climate change. Maybe it's something about developing AI. Maybe it's something we haven't encountered yet. If the great filter is ahead of us, then every silent star system we observe isn't just empty. It's a warning. It's a civilization that didn't make it. A species that got this far and then ended. And somewhere out there, Another civilization at our level might be looking at our solar system and seeing the same thing: silence. They don't know if we're still here or if we've already failed. Chapter 4: The Zoo, Hypothesis and Other Uncomfortable Ideas. Let's consider another possibility that's both comforting and deeply unsettling. We're being watched, but they're choosing not to contact us. The zoo hypothesis suggests that advanced alien civilizations know we're here, but have decided to observe us without interference, like scientists studying animals in a wildlife preserve. We're in a cosmic zoo, and we're the exhibits. Why would they do this? Maybe we're not ready for contact according to some galactic standard. They want to see how civilizations develop naturally. There's a prime directive situation, like in Star Trek, where interference is forbidden. They find us interesting precisely because we don't know they're watching. This idea is simultaneously reassuring. We're not alone. Someone's watching over us. And disturbing. We're lab rats in a cosmic experiment. Or consider the dark forest hypothesis, popularized by science fiction writer Liu Cixin. The idea is that the universe is like a dark forest where every civilization is a hunter hiding in the shadows. Any civilization that reveals itself risks being destroyed by more advanced civilizations that see them as potential threats. In this model, the universe is teeming with intelligent life, but everyone is hiding in terror, afraid to make a sound. The silence we observe isn't because there's no one out there. It's because everyone is deliberately staying quiet. If this is true, then another civilization like ours would be facing the same terrifying choice: announce our presence and risk everything, or stay hidden and remain alone. Part 2. What would they be like? Chapter 5. Convergent Evolution and Universal Principles. Here's a fascinating question. If evolution happened again on another planet, would it produce something recognizable? Or would aliens be so different from us that we couldn't even communicate? On Earth, we have something called convergent evolution, the process where unrelated organisms independently evolve similar features because they're solving similar problems. Eyes evolved independently dozens of times. Flight evolved independently at least 4 times. Insects, pterosaurs, birds, and bats. Echolocation evolved separately in bats and dolphins. This suggests there might be universal solutions to universal problems. An eye is fundamentally a really good way to detect photons. If an alien civilization evolved on a planet with light, they probably have something like eyes. Let's think about what might be universal: intelligence itself. If natural selection favors problem-solving ability, which it seems to on Earth, then intelligence might emerge wherever complex life exists. It's a tremendously useful adaptation. Communication. Any species that develops intelligence probably needs to share information. They'd have some form of language, though it might be chemical, visual, or something we can't imagine. Tool use. To build a technological civilization, you need to manipulate your environment. That probably requires something like hands, tentacles, or manipulator appendages of some kind. Mathematics. Math isn't invented, it's discovered. The ratio of a circle's circumference to its diameter is pi, regardless of what planet you're on. An alien civilization would discover the same mathematical truths we have. Physics and chemistry. The laws of physics are universal. An alien scientist and a human scientist, if they could communicate, would agree on the fundamental forces, the periodic table, and the speed of light. But here's where it gets interesting. While the fundamentals might be the same, the details could be wildly different. Chapter 6. Their world, their biology. Let's imagine what a planet hosting a civilization like ours might actually look like. First, it probably needs to be roughly Earth-sized. Too small, and it can't hold an atmosphere. Too large, and surface gravity might make it impossible for large organisms to evolve. Imagine trying to build technology when you weigh 5 times what you should. It needs to orbit in the habitable zone of its star, not too close, too hot, not too far, too cold. But here's the thing. Habitable zone is a pretty wide range, and conditions within it can vary dramatically. If their star is hotter and bluer than our sun, their planet would need to orbit further out, but would receive more UV radiation. They might have evolved completely different biochemistry to handle this. Their version of photosynthesis might work differently. Their vegetation might not be green, it could be black to absorb more light, or completely different colors we'd find bizarre. If their star is cooler and redder than our sun, their planet would orbit closer in. It might be tidally locked, with one side always facing the star. Life might exist only in the twilight zone between the scorching day side and the frozen night side. Their civilization might have very different concepts of time and day/night cycles. Their biochemistry. We're carbon-based because carbon is really good at forming complex molecules. Silicon is sometimes suggested as an alternative, but it's probably not as versatile. Still, alien life might use different amino acids, different genetic molecules, maybe not DNA, or even different solvents, maybe liquid methane instead of water at very cold temperatures. Their bodies. This is where our imagination often fails us. We tend to picture aliens as humanoid because that's familiar, but evolution on another planet could go in completely different directions. They might be radially symmetrical instead of bilaterally symmetrical, like a starfish, but intelligent. Collective organisms. What if their individual is actually a colony, like a Portuguese man-o'-war, but smart? Much smaller or larger than us, though probably within an order of magnitude. Physics constrains size pretty heavily. Have different numbers of limbs, eyes, or sensory organs we don't have. But here's what's probably true. If they built a technological civilization, they need some way to sense their environment, vision, hearing, echolocation, etc. Some way to manipulate objects. You can't build a radio telescope with hooves. Enough brain power for abstract thought, social organization. Technology seems to require cooperation. Chapter 7. Their society and culture. Now we get to the really interesting part. What would their society look like? Would they have art? Almost certainly. Even birds make art. Bowerbirds create elaborate decorative displays. The drive to create beauty seems to be linked to intelligence and social signaling. Their art would look completely alien to us, but they'd have it. Would they have music? Probably, if they can hear. Music is math plus emotion, and both of those seem like universal features of intelligence. Their music might be in frequency ranges we can't hear, or have rhythms that seem random to us, but it would serve similar purposes: bonding, emotional expression, cultural identity. Would they have mathematics and science? Absolutely. You can't build a technological civilization without understanding math and physics. They might have discovered these things in a different order than we did, or have different notation, but the underlying truths would be the same. Would they have war? This is a depressing but important question. On Earth, warfare seems to be linked to resource competition and tribalism. If these are universal features of evolved intelligence, which they might be, then yes, they probably have conflict and maybe warfare. But, and this is crucial, if they've survived to build a technological civilization, they've figured out how to not destroy themselves. They've found some way to manage conflict, limit destruction, or transcend their violent instincts enough to persist. That might be the most important lesson they could teach us. Would they have inequality? Again, probably. Hierarchies emerge naturally in social species. But what kind of inequality? Based on what? And have they found ways to manage it that we haven't? Would they have religion or philosophy? Here's a fascinating question. We developed religion partly to explain the unknown and partly to create social cohesion. Would aliens do the same? They'd probably have philosophy. The tendency to ask, why are we here, seems linked to self-awareness. But their conclusions might be completely different from ours, shaped by their biology and environment. Maybe they don't have individuals the way we do, and so their entire philosophical framework is collective rather than individual. Maybe their evolutionary history led them to a completely different ethical system. Maybe they solved the trolley problem in a way we've never considered. Would they have humor? Maybe. Humor seems to be linked to intelligence and social bonding, but what makes them laugh might make no sense to us at all. Chapter 8. Their technology. Let's think about what technology a civilization like ours would have. If they're at roughly our level of development, let's say within a century or two, which is nothing on cosmic scales, their technology might be surprisingly similar to ours in function, even if it looks completely different. They'd probably have communications technology. They need to share information across distances, whether it's radio waves, optical signals, or something else. They'd have some way to communicate. Energy generation. You can't build a civilization without energy. They might use solar, nuclear, fusion, or some power source we haven't discovered, but they'd need to harness energy at massive scales. Transportation. They'd need to move themselves and resources around their planet. Vehicles of some kind, probably. If they're in space, rockets or some other propulsion system. Computing. Information processing is probably universal to advanced civilizations. Their computers might be biological, quantum, optical, or based on principles we don't understand, but they'd have some way to process complex information. Medicine. If they care about their own survival, which they must, or they wouldn't have made it this far, they'd have developed ways to fix their bodies when they break. But here's where it gets interesting. Their technology might have taken completely different paths than ours. What if they never discovered fire? If they're aquatic or evolved in an oxygen-poor atmosphere, they might have developed technology without ever having combustion. Their entire technological tree would be different from ours. What if they're hive minds? Their internet might be biological, direct brain-to-brain communication. They might not need phones or computers because they're already networked. What if they're much longer lived than us? A species that lives for thousands of years would approach technology completely differently. They could work on projects that span millennia. Their patience and time horizons would make ours look absurdly short. What if they're much shorter lived? A species that lives only a few years might develop incredibly fast, iterative technology. Their entire civilization might transform every generation in ways that would seem frantic and unstable to us. Part 3: The Contact Question. Chapter 9: How would we find them, and they us? So let's say there is another civilization like ours out there. How would we detect each other? Radio signals. This is what we've been looking for with SETI, Search for Extraterrestrial Intelligence, since the 1960s. We're listening for artificial radio signals from space. The logic is that any technological civilization would generate radio waves, either deliberately sending messages, or incidentally, radio and TV broadcasts leaking into space. But here's the problem. Radio signals degrade with distance. Our TV broadcasts from the 1950s have only traveled about 70 light years. They're getting weaker and harder to detect as they spread out. A civilization more than a few hundred light years away might not be able to detect our accidental radio noise. And if they're more advanced than us, they might not use radio anymore. We were already moving toward fiber optics and directed signals that don't leak into space. A civilization just a few hundred years ahead of us might be completely radio silent. Optical signals. Some scientists are now looking for laser pulses from other civilizations. Lasers can be more efficient for interstellar communication than radio. Brief, powerful laser pulses could be detectable across thousands of light years. Megastructures. If a civilization is advanced enough, they might build structures so large we could see them from light years away. The most famous is a Dyson sphere, a structure built around a star to capture all its energy. We're looking for stars that dim in unusual ways that might indicate artificial structures. Atmospheric biosignatures. With powerful enough telescopes, we can analyze the atmospheres of distant planets. Certain combinations of gases, like oxygen and methane together, might indicate life. Industrial pollutants might indicate civilization. In a disturbing twist, we might be detectable to aliens through our pollution. Direct exploration. The most certain way to find another civilization would be to physically go there. But with our current technology, even reaching the nearest star would take thousands of years. Unless someone invents faster than light travel or generation ships, direct contact is probably off the table for now. Here's the thing that keeps astronomers up at night. We might have already seen evidence of other civilizations and not recognized it. What if we've detected their signals but dismissed them as natural phenomena? What if their technology is so advanced that it looks like natural processes to us? Chapter 10: The Great Timing Problem. Even if there are many civilizations out there, there's a timing problem that makes contact unlikely. Think about it. Humans have only been capable of detecting radio signals for about 120 years. That's 0.0000087% of Earth's history. We've only been transmitting signals that could be detected by aliens for about 100 years. If another civilization is out there, what are the odds that their 100-year window of being detectable overlaps with our 100-year window of being able to detect them? The universe is 13.8 billion years old. The window where two civilizations are both technological and detectable might be incredibly brief. We might be listening for civilizations that won't exist for another million years. Or we might be missing civilizations that existed a billion years ago and are now silent or transcended. It's like two people trying to meet in a train station, but neither knows when the other will be there. And the train station has been open for billions of years. The odds of showing up at the same time are not great. Part 1. Complete. Approximately 3,600 words. Continuing with the rest of Part 1 to reach 7,000 words. Chapter 11. What it would mean for us. Let's get philosophical for a moment. What would it actually mean for humanity if we discovered another civilization like ours? It would answer the oldest question: are we alone? For thousands of years, humans have looked at the stars and wondered. Every religion, every philosophy has grappled with our place in the cosmos. Discovering we're not alone would be the biggest paradigm shift in human history. It would shatter our uniqueness. Right now, human civilization is the most complex thing we know about in the universe. We're special, the only known beings that write poetry, do calculus, and wonder about our existence. Discovering another civilization would mean we're not unique. We're one of many. How would that change how we see ourselves? It would give us perspective. Every petty conflict we have, political, religious, national, would suddenly seem incredibly small. Our tribal divisions might start to feel absurd when faced with the reality that we are all humans together, sharing a cosmic neighborhood with others. It would terrify us. Let's be honest. Humans don't have a great track record with first contact. Every time in human history, when a more advanced civilization has encountered a less advanced one, it's gone badly for the less advanced civilization. Would aliens be different? We don't know, and that uncertainty is frightening. It would change our trajectory. If we discovered that another civilization exists and has survived for millions of years, that would tell us something crucial. It's possible to survive. We're not inevitably doomed. The great filter might be behind them, which means it might be passable. Or if we discovered they went extinct, that would be an urgent warning. There's something ahead that killed them. Whatever it is, we need to figure it out and avoid it. It would force us to grow up. Right now, humanity acts like an angsty teenager, convinced we're the center of everything, acting out, taking stupid risks. Discovering other civilizations would force us into a kind of cosmic adulthood. We'd have to take our role as a spacefaring species seriously. Chapter 12. The message problem. Let's say we do detect another civilization. How do we communicate? This is way harder than it sounds. First, there's the language problem. We don't share any common language, obviously. But it's worse than that. We might not even have compatible sensory systems. What if they communicate through color patterns we can't see? Or chemical signals we can't smell? Or time-based patterns that happen too fast or slow for us to notice? Then there's the conceptual problem. Our entire way of thinking is shaped by being human, by having human brains, human biology, human history. An alien intelligence might think in ways so different that communication is impossible. It would be like trying to explain love to a computer or teach a fish about dry land. Scientists have proposed various approaches: mathematics, This is considered the universal language. Concepts like prime numbers, pi, and basic geometry should be the same everywhere. A message based on mathematical principles might be our best shot at being understood. Pictures. The famous Arecibo message, sent in 1974, was essentially a bitmap picture containing information about DNA, human figures, the solar system, and other basics. Visual information might transcend language barriers. Physical artifacts. The plaques on the Pioneer spacecraft and the golden records on Voyager contain pictures and sounds meant to tell aliens about us. Of course, they'd need to intercept these spacecraft and figure out how to play the records, which is a big ask. But here's the really mind-bending part. Even if we successfully send a message, we might not get a reply for centuries or millennia. Light speed is the speed limit of the universe, as far as we know. If another civilization is 1,000 light years away, our message takes 1,000 years to reach them. Their reply takes another 1,000 years to reach us. That's a 2,000-year delay for a simple back and forth. This means interstellar communication would be less like a conversation and more like messages in bottles thrown across a cosmic ocean, hoping someone finds them thousands of years later. Chapter 13. The Simulation Hypothesis. Here's a wild card that we can't ignore. What if there are other civilizations like ours because we're all simulations? The simulation hypothesis suggests that we might be living in a computer simulation created by an advanced civilization. And if that's true, there could be many simulations running simultaneously, each containing civilizations like ours. The logic goes like this. 1. If it's possible to create sufficiently realistic simulations of conscious beings, advanced civilizations will probably create them too. If they create them, they'll probably create lots of them. 3. Therefore, there are probably many more simulated realities than base realities. 4. So statistically, we're more likely to be in a simulation than in base reality. Philosopher Nick Bostrom formalized this argument, suggesting that at least one of 3 things must be true. Civilizations never reach the point where they can create realistic simulations. Advanced civilizations choose not to create simulations for some reason. We're almost certainly in a simulation. If we're in a simulation, then another civilization like ours might mean another simulated civilization in a different instance of the simulation, or in a parallel simulation running on the same cosmic computer. This is either the answer to everything or completely unfalsifiable pseudoscience, depending on who you ask. But it's a reminder that reality might be weirder than we can imagine. Part 4, the parallel development theory. Chapter 14, could they be going through the same things we are? Here's where things get really interesting. If there's another civilization at roughly our level of technological development, give or take a few centuries, they might be facing the exact same challenges we're dealing with right now. Think about it. The path from primitive organisms to technological civilization probably has certain inevitable milestones. You need to discover fire or some equivalent energy source. You need agriculture or some way to generate surplus food. You need writing or some form of information storage. You need mathematics and science. And at each stage, you face certain challenges that might be universal. The energy crisis. Every developing civilization needs more and more energy. We went from burning wood to coal to oil to nuclear to renewables. Another civilization would face the same energy ladder. They'd start with whatever simple energy source is available on their planet, then climb toward more efficient and powerful sources. They're probably having the same debates we are. How do we generate enough energy for our growing civilization without destroying our environment? How do we transition from dirty but easy energy to clean but difficult energy? The climate problem. If they're burning fossil fuels or some alien equivalent, they're probably changing their climate. The physics of greenhouse gases isn't planet-specific. Carbon dioxide traps heat regardless of what planet you're on. So right now, somewhere out there might be alien scientists showing increasingly alarming data to alien politicians who are too worried about the next election cycle to take it seriously. There might be alien climate activists protesting in alien streets. There might be alien coal miners worried about their jobs. The specifics would be different, but the fundamental tension, short-term economic concerns versus long-term survival, might be universal. The nuclear question. Once you understand atomic physics, you can build atomic weapons. It's not optional. The knowledge leads directly to the capability. So any civilization that reaches our level of physics knowledge probably faces the same terrifying question. How do we live with the power to destroy ourselves? They might have had their own Cuban Missile Crisis moment. They might have signed their own version of nuclear non-proliferation treaties. They might be struggling with the same paradox we are. Nuclear weapons might be so terrible that they prevent large-scale war, but they also mean that any war could be the last war. The AI dilemma. If intelligence is a useful trait, which it clearly is, or we wouldn't exist, then artificial intelligence is probably an inevitable development for any technological civilization. And with AI comes enormous questions. Do we remain in control? At what point does AI become conscious, if it does? How do we ensure it shares our values? What happens to our purpose and identity when machines can do everything we can do, but better? An alien civilization at our level is probably grappling with these same questions. They might be ahead of us, having already solved the AI control problem. Or they might be behind us, not having reached that point yet. Or, and this is sobering, they might have already failed, destroyed, or displaced by their own creation. Chapter 15. The Social Media Age. Here's something that might sound silly, but is actually profound. Another civilization like ours probably has social media. Once you have a global communication network, devices that let individuals broadcast to large audiences, algorithms that curate content, you inevitably get something like social media. The details would be different, but the basic concept, instant global communication with viral information spread, seems almost inevitable. And you know what that means? They're probably dealing with all the same problems we are. Misinformation. The ability to spread information quickly also means the ability to spread false information quickly. They probably have their own version of fake news, conspiracy theories, and information warfare. Maybe their civilization is splitting into information bubbles, where different groups literally perceive different realities because they're consuming different media. Maybe they're struggling with how to preserve free speech while combating dangerous misinformation. Maybe they've figured out solutions we haven't. Polarization. social media seems to amplify extreme views and demonize opponents. This might be a universal property of how information networks interact with tribal social instincts. Another civilization might be watching their society fragment into opposing camps that can't even agree on basic facts. Or maybe they found a way around this. Maybe their biology makes them less susceptible to tribalism. Maybe their technology includes safeguards we haven't thought of. Maybe their culture developed norms that prevent polarization. The attention economy. Once you have limited attention and unlimited content competing for it, you get an attention economy. They probably have their version of clickbait, rage bait, and addictive content designed to hijack their reward systems. Maybe they're having the same debates we are about screen time, digital wellness, and whether their technology is making them happy or miserable. Privacy versus security. The same technology that lets them connect and share also lets them surveil and control? They're probably navigating the same treacherous territory we are. How much privacy are we willing to sacrifice for security? Who watches the watchers? What happens when corporations or governments know everything about everyone? Chapter 16. The biological wildcard. Here's something we haven't fully considered. What if their biology makes them fundamentally different from us in ways that completely change their civilization? What if they reproduce differently? Humans have sexual reproduction with 2 biological sexes, pregnancy, childhood, and family units. What if they don't? Imagine a species that reproduces by budding, creating genetic clones. Their entire concept of family, identity, and individuality would be alien to us. They might not even have a concept of parent or child the way we do. Or imagine a species with 3 or more biological sexes required for reproduction. Their gender dynamics, family structures, and social organization would be completely unlike ours. Or a species that reproduces rarely but lives for thousands of years. Their civilization would be incredibly stable, with individuals accumulating vast amounts of personal experience. But they might also be conservative and slow to change, since why innovate when you've got millennia to perfect existing methods? What if they don't have individuals the way we do? I mentioned this earlier, but it deserves deeper thought. What if their person is actually a colony, organism like a Portuguese man-o'-war, where what looks like an individual is actually many organisms working together? Or what if they're a true hive mind, where individuals have limited autonomy but are connected to a collective intelligence? Their civilization wouldn't have the same tension between individual and collective good that plagues our politics. But they might have completely different problems we can't imagine. What if they don't die, or die very differently? Human civilization is profoundly shaped by mortality. We have religions partly because we're terrified of death. We have urgency because our time is limited. We pass knowledge through generations because individuals don't live long enough to learn everything. What if they don't die of old age? What if they can regenerate indefinitely, like some jellyfish on Earth? Their attitude toward risk, time, and change would be completely different from ours. Or what if they die regularly but retain memories? Somehow, some form of reincarnation or genetic memory transfer? They'd have continuity of personal experience across generations in ways we can only dream of. What if they don't sleep? Humans spend 1/3 of our lives unconscious. Our entire civilization is built around sleep cycles, night and day, work and rest. What if they don't need sleep? They'd be productive 24/7, but they might also lack the psychological reset that sleep provides. Do they dream? If not, what does that do to creativity? Part 5, The Evolution of Civilizations, Chapter 17, The Kardashev Scale and Civilizational Progress. In 1964, Soviet astronomer Nikolai Kardashev proposed a scale for measuring a civilization's technological advancement based on energy consumption. It's become the standard way to think about civilizational progress. Type 1. Civilization can harness all the energy available on their planet. This includes weather control, earthquake prevention, and complete mastery of their environment. We're not there yet. We're currently about 0.73 on the Kardashev scale. Type 2, civilization, can harness all the energy output of their star. We're talking Dyson spheres, stellar engines, and power available on scales we can barely imagine. This is Star Trek territory. Type 3, civilization, can harness the energy of their entire galaxy. At this level, they're manipulating the fabric of space-time, building artificial wormholes, and treating star systems like we treat cities. If there's another civilization like ours, they're probably also a type 0.7 to 0.8 civilization. Not yet planetary, but getting there. And here's the thing. The jump from type 0 to type 1 is probably the most dangerous transition a civilization makes. It's where you have enough power to destroy yourself, but not enough wisdom to ensure you don't. Think about it. We have nuclear weapons, genetic engineering, artificial intelligence, and climate-altering industry. We're playing with forces that could end our civilization, but we're still using tribal political systems designed for groups of a few hundred people. Another civilization at our level is probably in the same precarious position. They're climbing the same dangerous slope. They might fall. We might fall. Or we might both make it to the other side and become type 1 civilizations. Chapter 18, The 3 Paths. Looking at the trajectory of civilizations, there seem to be 3 possible paths forward. Another civilization like ours is probably on one of these paths, just like we are. Path 1, extinction or collapse. This is the dark possibility. The civilization fails to solve one or more existential problems and either goes extinct or collapses back to a pre-technological state. This could happen through nuclear war, climate catastrophe, pandemic, natural or engineered, AI gone wrong, resource depletion, asteroid impact, if they're unlucky. Something we haven't thought of yet. If this is common, it would explain the Fermi Paradox. The universe might be full of ruins, planets that once hosted civilizations but no longer do. The terrifying implication is that we might be looking at our own future. If most civilizations don't make it past this stage, why would we be different? Path 2, stagnation. Maybe they survive but stop advancing. They reach a stable equilibrium, sustainable but not growing, safe but not ambitious. Maybe they solve all their existential problems by becoming very conservative and risk-averse. They give up on space exploration, AI development, and other dangerous technologies. They create a stable, long-lasting civilization that could persist for millions of years, but never advances beyond a certain point. This would also explain the Fermi Paradox. They're out there, but they're staying home, being quiet, and not expanding into space because expansion is risky. The question is, would this be a good outcome? Is a stable, sustainable, but stagnant civilization preferable to a dynamic but risky one? Different philosophies would answer this differently. Path 3: Transcendence. This is the optimistic path. The civilization not only survives but continues to advance, eventually becoming something far beyond what they started as. This could mean merging with their technology to become post-biological, uploading their consciousness into digital form, spreading through space to become a spacefaring civilization, manipulating the laws of physics in ways we can't currently imagine, evolving or engineering themselves into something we wouldn't recognize. If this is common, it might also explain the Fermi Paradox. Advanced civilizations might be so different from us that we don't recognize them. They're not hiding, we're just looking for the wrong things. An ant can't perceive a radio wave, even though the air is full of them. Maybe we're like ants, surrounded by super advanced civilizations that we literally can't perceive because they've transcended our ability to detect them. Chapter 19: The Cultural Evolution Question. Here's a question that doesn't get asked enough. Would their culture evolve along similar lines to ours? On Earth, human cultures evolved independently in different places and developed similar concepts. Art, music, storytelling, religion, law, ethics. Does this mean these are universal features of intelligent social beings, or are they specific to human psychology? Would they have art? Probably yes. The impulse to create beyond pure utility seems to be linked to intelligence. Even crows and dolphins show signs of playfulness and creativity. But their art would be shaped by their sensory systems and psychology. If they see in ultraviolet or infrared, their visual art would be invisible to us. If they communicate through scent, their poetry might be composed of chemical combinations. If they perceive time differently, their music might operate on scales we can't comprehend, symphonies that take years to play, or rhythms that change so fast we hear them as a single note. Would they have stories? Narrative seems to be how intelligent beings make sense of cause and effect. We tell stories about everything: history, science, our own lives. An alien civilization probably also organizes information narratively, but their story structures might be completely different from ours. Human stories typically have a beginning, middle, and end. We like heroes, conflicts, and resolutions. But what if their psychology doesn't work that way? What if they think in loops, or spirals, or patterns we can't recognize as narratives at all? Would they have humor? Humor seems to be linked to pattern recognition and social bonding. We laugh when expectations are subverted in safe, non-threatening ways. Would aliens have the same response? Maybe. But what makes them laugh might make no sense to us. Our jokes might seem incomprehensible or even disturbing to them. Imagine trying to explain sarcasm or puns to a species that doesn't think like we do. Would they have morality? This is huge. Do universal ethics exist, or is morality entirely cultural? There are some moral intuitions that seem widespread in human cultures. Don't kill members of your own group unnecessarily. Reciprocate kindness. Care for your offspring. These might emerge from the requirements of social living. But aliens might have completely different moral foundations. What if they're not social the way we are? What if they don't have families? What if they evolved as solitary predators who only come together to reproduce? Or what if they're more social than us, truly collective organisms where individual sacrifice for the group is automatic and unquestioned? Their ethics might consider our individualism selfish and pathological. Chapter 20. The Religion. Question: would another civilization have religion? This depends on what you mean by religion. If you mean belief in supernatural beings, maybe not. That might be specific to how human brains work. But if you mean systems of meaning and purpose, rituals that bind communities together, explanations for existence, then probably yes. Every human culture has developed some form of religion or philosophy that addresses big questions. Why are we here? What happens when we die? How should we live? What is our place in the universe? An alien civilization probably asks the same questions. Their answers might be radically different from ours, but the impulse to seek answers seems fundamental to consciousness. What if they figured out the answers? This is an interesting possibility. Maybe they discovered some fundamental truth about existence that we're still missing. Maybe they have scientific proof of what happens after death. Maybe they've solved the hard problem of consciousness and know exactly what they are and why they exist. Would this make them more peaceful? More purposeful? Or would certainty about existence make them complacent or fanatical? What if they're still searching, like us? Maybe they have 1,000 different religions and philosophies, just like we do. Maybe they're still arguing about it, still writing theology and philosophy, still wondering if there's something beyond the physical universe. In a way, this might be the most likely scenario. The big questions might not have clear answers, so every civilization, human or alien, might be eternal seekers, forever asking without ever fully knowing. Part 6. The Contact Scenarios, Chapter 21. First Contact, the best case. Let's imagine the best case scenario. We detect a signal from another civilization. After years of analysis, we confirm it's artificial. After more years of effort, we decode a message. What would it say? In the optimistic scenario, it would be a greeting. Hello? We're here. We're like you. You're not alone. Maybe they've already figured out some of the problems we're facing. Maybe the message includes solutions to climate change, sustainable energy, or how to develop AI safely. Maybe they're offering help. Or maybe the message is just data. Here's what we know. Here's our math, our science, our understanding of the universe. Learn from our discoveries. Even just knowing they exist and survived to send the message would be incredibly valuable. It would prove that civilizations can make it through the danger zone we're currently in. The great filter, whatever it is passable. What would we send back? This is actually a source of heated debate among scientists and philosophers. Should we reply at all? Some argue yes, obviously. We should introduce ourselves, share our knowledge, begin a dialogue that could transform both civilizations. Others argue no, emphatically not. We don't know who or what they are. Announcing our presence might be dangerous. We should listen, but stay silent until we know more. If we do reply, what should we say? Who gets to speak for humanity? What if different groups want to send different messages? What if governments want to send one message and scientists another? This isn't hypothetical. These are real debates happening right now among SETI researchers and international space policy experts. Chapter 22. First contact. The worst case. Now the dark scenario. We detect a civilization and it goes badly. Scenario 1. They're hostile. Maybe they're expansionist and see other civilizations as threats or resources. Maybe their biology or psychology makes them inherently aggressive. Maybe they've survived this long precisely because they eliminate potential rivals. In this scenario, detecting us is the worst thing that could happen. We'd be advertising our location to something that wants to destroy or conquer us. The good news? Interstellar distances are vast. Even if they're hostile, traveling here would take them centuries or millennia with any technology we can imagine. We'd have warning. The bad news? A civilization advanced enough to travel between stars might have weapons we can't imagine. Relativistic kill vehicles, objects accelerated to near light speed, stellar engineering that could destabilize our sun, or technologies that seem like magic to us. Scenario 2. We're the primitive ones. What if the civilization we contact is thousands or millions of years ahead of us? We'd be to them what ants are to us. Would they care about us at all? Would they have any interest in communicating with beings so far beneath their level? Or would we be as significant to them as bacteria are to us? Interesting to study, perhaps, but not to engage with as equals. Scenario 3. The message is a warning. What if we decode the message and it says, "Stay quiet. Don't let them find you. They're listening." What if the universe is dangerous in ways we don't understand? What if there's a predator civilization out there and the other prey civilizations have learned to hide? This is the dark forest scenario again, but confirmed. The silence of space isn't because there's no one out there, it's because everyone is hiding in terror. Scenario 4. It's a trap. Some science fiction writers have suggested that a message from space might be a virus, information designed to hack any mind that processes it. Or instructions for building technology that looks beneficial but is actually a Trojan horse. This sounds paranoid, but it's worth considering. Information can be dangerous. Instructions for building a doomsday weapon would be bad to receive. A message designed to manipulate our psychology could be subtle and devastating. Chapter 23. The non-contact scenarios. But here's the thing. The most likely scenario isn't contact at all. It's continued silence. Scenario 1. They exist, but we never find each other. The universe is so vast, and civilizations are so brief, on cosmic timescales, that two civilizations might exist but never detect each other. We might be looking in the wrong direction. They might have existed 1 billion years ago, or might exist 1 billion years from now. We might be ships passing in the night, separated by space and time. Scenario 2. They exist, but we can't recognize them. Maybe we've already detected signs of other civilizations, but dismissed them as natural phenomena. Maybe their technology is so advanced, it looks like natural processes to us. Maybe they're everywhere, and we're just too primitive to see it. Scenario 3. They existed, but they're gone. This is the ruins scenario. Maybe the universe was once full of civilizations, but they're all extinct now. We're latecomers to a party that ended 1 billion years ago. The galaxy is full of dead worlds, archaeological sites we'll never visit, stories we'll never hear. This would be both reassuring, we're not in danger from them, and deeply sad, we've missed our chance to meet our cosmic siblings. Scenario 4. We're early. Maybe intelligent life is rare and takes a long time to develop. Maybe Earth is one of the first planets to produce a technological civilization. Maybe we're the ancestors, the elders, the first civilization that will eventually spread through the galaxy. This would be an enormous responsibility. Everything we do would matter because we'd be setting the template for how civilizations behave. We'd be the first movers, and our choices would echo through cosmic history. Part 7: The Psychology of Not Being Alone. Chapter 24: How it would change everything we think we know. Let's get personal for a moment. How would the confirmed existence of another civilization change you individually? Right now, you probably think of yourself primarily as a human, maybe specifically as American, Chinese, Brazilian, whatever. You have national identity, ethnic identity, religious identity. These categories define how you see yourself and others. But the moment we confirm another civilization exists, something profound shifts. Suddenly, all humans are on the same team. The category that matters isn't American versus Chinese or Christian versus Muslim. It's human versus alien. This has happened before on smaller scales. When European explorers met isolated indigenous peoples, both groups suddenly had to recategorize themselves. The indigenous people weren't just the people anymore. They were one people among many. The Europeans weren't the center of the world. They were visitors from somewhere else. But this would be that realization on a cosmic scale. Your problems would feel smaller. That argument you had with your coworker, the political issue you're passionate about, the sports team you root for, all of it would suddenly feel incredibly parochial. Not that these things wouldn't matter. They would, because they're still your life, but they'd matter in a different context. It's like how your personal problems don't disappear when you learn about global poverty, but they might feel less consuming. Your potential would feel larger. Right now, the greatest achievements of humanity are things like landing on the moon, building the pyramids, creating the internet. These are the ceiling of what we've accomplished. But if another civilization exists, especially if they're more advanced than us, suddenly the ceiling lifts. All those science fiction dreams, interstellar travel, unlimited clean energy, post-scarcity economics, radical life extension, they'd stop being fantasy and become achievable goals because someone else achieved them. Your existential dread might shift. A lot of people worry about death, meaninglessness, the eventual heat death of the universe. But if other civilizations exist, if consciousness is common in the universe, then maybe we're part of something larger and more enduring than we thought. Or maybe it would make existential dread worse. Maybe knowing we're not unique would make us feel less special, less significant. Maybe the universe being full of civilizations would make any individual civilization seem less important. Your sense of time would warp. Think about how we measure human history. Ancient Egypt was 5,000 years ago and feels impossibly distant. But if another civilization has existed for millions of years, suddenly 5,000 years is nothing. Our entire recorded history would be a blip. This might make us more humble about our place in time, or it might make us more ambitious. If they can last that long, maybe we can too. Chapter 25: The Philosophical Implications. The existence of another civilization would force us to reconsider some deep philosophical questions. Are we significant? Right now, we can tell ourselves that consciousness is rare and precious, that human beings are the universe's way of understanding itself. We're special. But if civilizations are common, then we're not special. We're one of many, maybe one of millions. Does that make us less significant, or does it mean significance works differently than we thought? Maybe significance isn't about being unique. Maybe it's about being part of a larger story. Maybe being one of many conscious species in the universe is more meaningful than being the only one, because it means we're part of a cosmic community. Is there purpose? Many religions and philosophies assert that existence has purpose, often tied to humanity's special role in creation. But if we're not special, if we're just one civilization among many, what's the purpose? Maybe the purpose is the same as it always was: to survive, to learn, to create, to experience. But now we understand that this purpose is shared across the universe. Or maybe there is no cosmic purpose, and that's okay. Maybe purpose is something each civilization creates for itself, and there are as many purposes as there are conscious beings. What is consciousness? If multiple civilizations have developed consciousness independently, that tells us something important. Consciousness is probably not a freak accident. It's something that emerges under the right conditions. But what are those conditions? Is consciousness a fundamental property of the universe, like gravity? Or is it an emergent property of complex information processing? And if aliens have consciousness, is their subjective experience anything like ours? This gets into the hard problem of consciousness. We don't even fully understand our own consciousness, let alone how to detect or measure it in something else. What should we value? Human ethics are generally human-centered. We care about human suffering, human rights, human flourishing. But if there are other conscious beings out there, do they deserve the same moral consideration? This isn't just academic. If we ever encounter another civilization, we'll need to decide: do they have rights? Can we make deals with them? Can we compete with them? Under what circumstances, if any, would conflict be justified? These questions are versions of ethical debates we're already having about animal consciousness and potential AI consciousness, but scaled up to a cosmic level. Chapter 26: The Hope and the Horror. Let's be honest, the idea of another civilization existing is both deeply comforting and profoundly terrifying. The hope: we're not alone. In this vast, dark, cold universe, there are others like us. Other beings who think, who wonder, who create, who love in whatever way they love. When we look at the stars, we're not looking at empty darkness. We're looking at neighborhoods we haven't visited yet. There are minds out there, experiencing their own version of existence, asking their own questions, building their own civilizations. If they've survived as long or longer than us, it means survival is possible. Whatever challenges lie ahead, climate change, AI, resource depletion, whatever, they can be overcome. We have proof. And maybe someday we'll meet them. Maybe we'll share knowledge, art, philosophy. Maybe we'll learn that consciousness, in all its forms, is fundamentally similar. That beneath the alien biology and strange culture, there's a recognizable mind-thinking thoughts we can relate to. Maybe they've already solved problems we're struggling with. Maybe they can teach us. Maybe together, we can accomplish things neither civilization could do alone. The horror? We don't know what they're like. We don't know if they're peaceful or aggressive. We don't know if they'd see us as equals, as inferiors, or as resources to be exploited. History on Earth doesn't give us much reason for optimism. When a more advanced civilization encounters a less advanced one, it generally goes badly for the less advanced one. Colonization, exploitation, genocide, these are patterns we've seen repeatedly. Would aliens be different? We hope so, but we don't know. Maybe any species that becomes spacefaring has transcended such primitive behaviors. Or maybe violence and exploitation are universal strategies, successful everywhere. And there's another horror. Maybe we're the dangerous ones. Maybe we're the aggressive species. And if we ever gain the ability to travel to other worlds, we'll become the colonizers, the exploiters. Maybe the reason space is silent is because quieter, more peaceful civilizations have learned to hide from species like us. Or maybe we are all dangerous. Maybe the universe is full of civilizations that would destroy each other if they met, and the vast distances between stars are the only thing keeping us safe from mutual annihilation. The uncertainty. The truth is, we don't know, and that uncertainty is perhaps the hardest part to live with. We could be alone, the only consciousness in the observable universe, a cosmic fluke that will never be repeated. Or we could be one of trillions, so common as to be unremarkable. We could be in danger from hostile aliens actively hunting for civilizations like ours. Or we could be perfectly safe, surrounded by peaceful civilizations that would welcome us with open arms if we could just find them. We could be infants on the cosmic stage with millennia of growth ahead. Or we could be in our final days, about to fail some test that all civilizations face. We don't know. And until we find another civilization or prove that none exist, we won't know. Living with that uncertainty requires a kind of cosmic maturity, the ability to act wisely without knowing the full stakes, to prepare for possibilities without becoming paralyzed by fear. Part 8. What we can learn from the possibility. Chapter 27. The mirror of speculation. Even if we never find another civilization, thinking about their existence teaches us about ourselves. When we imagine what aliens might be like, we're really examining what we think is universal versus what's culturally specific. We're holding up a mirror to humanity and asking, what parts of us are fundamental to consciousness, and what parts are accidents of our particular evolutionary history? Technology. We assume other civilizations would develop technology because we did, and because technology seems to flow naturally from intelligence and tool use. But maybe that's human bias. Maybe there are forms of intelligence that don't lead to technology, or that lead to fundamentally different kinds of technology. Our technology is physical. We build machines, structures, devices. But what if another form of intelligence developed biological technology instead, engineering their own bodies and ecosystems rather than building separate tools? Or what if they developed consciousness-based technology, direct mental manipulation of reality in ways that look like magic to us, but are actually sophisticated applications of physics we don't understand? Thinking about alien technology forces us to question our assumptions about what technology is and what forms it can take. Society. We debate capitalism versus socialism, democracy versus authoritarianism, individual rights versus collective good. But these debates are all within a certain framework. They assume things like private property, individual identity, and scarcity of resources. An alien civilization might have completely different political and economic frameworks that don't map onto our categories at all. They might have solved the problems we're arguing about in ways we haven't imagined, or they might have completely different problems we've never faced. Thinking about how aliens might organize themselves helps us see our own social structures as choices rather than inevitabilities. We do things the way we do them because of our history and biology, not because they're the only possible ways. Values? We argue about what's right and wrong, what's good and what's bad. But how much of our morality is universal, and how much is specific to being human? Some things seem likely to be universal. Cooperation probably beats pure selfishness for any social species. Logic and math are the same everywhere, but other values might be human-specific. Do aliens value individual freedom? Do they fear death? Do they create art for beauty's sake? We assume these things are universal because they're universal to us, but maybe they're not. Thinking about alien values helps us distinguish between ethics that might be cosmic truths and ethics that are cultural constructs. Chapter 28, The Preparation Imperative. Here's a practical question. Should we prepare for the possibility of contact even if we think it's unlikely? Some scientists and philosophers say yes, absolutely. The consequences of contact would be so profound that we need to think about it in advance. We need protocols, plans, and international agreements about how to handle it. Right now, if we detected a signal from another civilization, there's no agreed-upon procedure for what to do next. Different countries might want to respond differently. Different organizations might compete for control of the communication. The situation could become chaotic very quickly. Organizations like the SETI Institute and the International Academy of Astronautics have proposed principles for what to do if we detect extraterrestrial intelligence. 1. Verify that the signal is actually from an extraterrestrial civilization. 2. Inform the public and the scientific community immediately. 3. Don't respond until there's international consultation. 4. Any response should be on behalf of all humanity, not one nation or group. But these are just proposals. They're not legally binding. There's no enforcement mechanism. If someone decided to respond to an alien signal without permission, there's not much anyone could do to stop them. Should there be laws about this? Some people argue that responding to alien signals should require international agreement, maybe through the United Nations. The stakes are too high for individuals or individual nations to act alone. Others argue that restricting communication violates free speech and scientific freedom. If someone wants to beam a message into space, who has the right to stop them? These debates are happening right now, and the answers will shape how humanity approaches the cosmos. Chapter 29, The Long-Term Perspective. Thinking about other civilizations forces us to think long-term in ways we usually don't. Human beings are bad at thinking long-term. Our brains evolved to handle immediate threats and opportunities, finding food, avoiding predators, forming alliances. We're not naturally good at thinking about what might happen in 100 years, let alone thousands or millions. But other civilizations, if they exist, operate on those timescales. A signal we send today might not be received for thousands of years. A reply might not reach us for thousands. More, this forces a perspective shift. Suddenly, The problems we're worried about this election cycle or this quarter's earnings seem absurdly short-sighted. We're making decisions that will affect humanity for generations, but we're thinking like mayflies. Climate change. We're changing our planet's climate in ways that will affect the next 10,000 years, but we're making decisions based on the next 10 years of economic growth. An alien civilization watching us would probably be baffled by this short-term thinking. If we took a cosmic perspective, if we thought about ourselves as a civilization that might exist for millions of years, we'd make very different choices about the environment. Space exploration. We are not investing heavily in space exploration, partly because the returns are decades or centuries away. But if we thought like a species planning to exist for 1 million years, space exploration would be an obvious priority. The resources in our solar system are vast, and we have all the time in the world to access them if we survive. Knowledge preservation. We're creating knowledge at an unprecedented rate, but most of it exists in fragile digital formats that might not last a century, let alone a millennium. From a cosmic perspective, we're being incredibly careless with our intellectual heritage. An advanced civilization would probably have robust systems for preserving knowledge across vast time periods. They'd think about information storage the way we think about nuclear waste storage. What formats will still be readable in 10,000 years? Cultural evolution. We tend to think of culture as fixed or slowly changing, but on cosmic timescales, cultures transform completely. The civilization that exists on Earth in 10,000 years might be as different from us as we are from prehistoric hunter-gatherers. If we take seriously the possibility that human civilization might last millions of years, we need to think about cultural evolution as an ongoing process, not a finished product. The values and systems we have now are just one moment in a long story. Chapter 30. What they might think of us. Let's flip the question. If there's another civilization observing us right now, what would they think? Imagine you're an alien scientist, and you've just detected Earth. You point your telescopes at this little blue planet and start analyzing. What do you see? The physics. Interesting. They figured out quantum mechanics and relativity. They understand nuclear fission and have started working on fusion. They've sent simple probes to nearby planets. They're at the leaving the cradle stage of development. The chemistry. Their atmosphere has an oxygen-nitrogen mix with rising CO2 levels. They're burning fossil carbon at an accelerating rate. This is typical of industrial civilizations, but the rate of increase is concerning. They don't seem to have transitioned to clean energy yet. The biology. The dominant species is a carbon-based bipedal mammal with bilateral symmetry. They have color vision, opposable thumbs, and relatively large brains. They're social and organize into groups of varying sizes. The communications. They emit vast amounts of electromagnetic radiation, radio, television, radar. Much of it appears to be entertainment rather than information. They have a global communication network connecting billions of devices. The content is chaotic. Lots of conflict, cooperation, creativity, and what appears to be arguing about trivial matters. The culture. They have thousands of distinct cultures with different languages, religions, and values. They've recently developed the ability to destroy themselves with nuclear weapons, but haven't used them in large-scale conflict for several decades. This is a critical period. They either unify and survive, or fragment and potentially collapse. The concerning signs. They're showing typical late industrial age warning signs: resource depletion, environmental degradation, political polarization, wealth inequality. They have the technology to solve these problems, but seem unable to coordinate action effectively. Their political systems are optimized for short-term tribal competition rather than long-term species survival. The hopeful signs. Despite conflicts, they're increasingly connected globally. They're developing artificial intelligence, which could either enhance their capabilities or replace them. They're showing interest in space exploration and have landed on their moon. Some segments of their population are thinking long-term about species survival. The verdict? Conclusion: civilization in critical transition phase. Outcome uncertain. Probability of survival to Type 1 civilization, 40 to 60%, depending on choices made in next 50 to 100 years. Recommend continued observation. That's probably the most honest assessment an alien observer could make. We're in the danger zone, and it's not clear which way we'll go. Part 9. The Practical Implications. Chapter 31. How this changes our priorities. If we take seriously the possibility that other civilizations exist, it should change what we prioritize as a species. Priority 1. Don't destroy ourselves. This seems obvious, but it takes on new urgency if we're one of many civilizations going through the same dangerous transition. Every civilization probably faces what we're facing, the challenge of having enough technology to destroy yourself, but hopefully enough wisdom not to. Some civilizations make it through, others don't. If we care about our place in the cosmic story, we need to make sure we're in the made it through category. That means taking existential risks seriously. Climate change isn't just an environmental issue, it's a survival test. Nuclear weapons aren't just a political issue, they're a civilizational threat. AI development isn't just a technology issue. It's a question of whether we remain in control of our future. Pandemic preparedness isn't just a health issue, it's about species resilience. Priority 2. Preserve knowledge. If we're going to be a civilization that lasts for thousands or millions of years, we need to get serious about knowledge preservation. Right now, most of our knowledge exists in formats that won't last even a century. Digital storage degrades. Servers fail. File formats become obsolete. In 1,000 years, will future humans be able to access what we knew? Some people are working on this. The Long Now Foundation is building a clock designed to run for 10,000 years. The Arctic World Archive stores data on special film that can last for centuries. But we need to think bigger. An advanced civilization would have knowledge preservation systems designed to survive planetary disasters, civilizational collapses, or technological dark ages. Priority 3, expand beyond Earth. If we stay on one planet, we're vulnerable to extinction from asteroid impacts, supervolcano eruptions, or other planetary-scale disasters. Every civilization that survives long-term probably becomes multiplanetary. It's just basic risk management. Don't keep all your eggs in one basket. This doesn't mean abandoning Earth. It means ensuring that if something catastrophic happens here, human civilization continues somewhere else. Priority 4, develop mature communication protocols. If there's a possibility of contact with another civilization, we should have plans for how to handle it. This includes who speaks for humanity, what should we say, what shouldn't we say, how do we verify that a signal is real, how do we handle disagreements about how to respond. Right now, these questions don't have clear answers, and that's a problem. Priority 5, balance curiosity with caution. We should continue looking for other civilizations. The potential benefits are enormous, but we should also be thoughtful about how we search and what we broadcast. Some scientists advocate active SETI, deliberately sending powerful signals into space to attract alien attention. Others argue this is reckless. We don't know what's out there, and advertising our presence might be dangerous. There's no consensus, and maybe there shouldn't be. But we should be having these conversations seriously, not leaving it to chance or individual actors. Chapter 32. The Educational Imperative. If another civilization exists, one of the most important things we can do is educate people about cosmic perspective. Right now, most people think locally and short-term. That made sense for most of human history, when your tribe and your lifetime were the relevant scales. But we now live in a globally connected world facing planetary scale challenges. And if we're part of a universe that might contain many civilizations, we need to think even bigger. Teach cosmic history. Students should understand that human history is a tiny slice of cosmic history. The universe is 13.8 billion years old. Earth is 4.5 billion years old. Humans have existed for about 300,000 years. Civilization for about 10,000 years. This perspective helps people understand that we're part of a much larger story. Our choices matter not just for us, but potentially for the entire future of consciousness in this region of space. Teach probability and scale. People struggle to understand very large numbers and very small probabilities. But these are essential for thinking about other civilizations. Understanding that 1 in a trillion events happen all the time in a universe with trillions of galaxies is important. Understanding that light years are really, really far is important. Understanding exponential growth is important. Teach systems thinking. Civilizations are complex systems. Climate, economy, technology, culture, everything connects to everything else. Understanding these connections helps people grasp why civilizational challenges are so difficult and why simple solutions often fail. Teach uncertainty. We don't know if other civilizations exist. We don't know if we'll survive the next century. We don't know what the future holds. Teaching people to be comfortable with uncertainty while still making good decisions is crucial. We need to act wisely even though we don't know everything. Teach hope without guarantees. The universe might contain other civilizations that have solved the problems we face. That's hopeful. But they might also be gone, destroyed by those same problems. That's sobering. The right attitude is, it might be possible to succeed, and that's worth fighting for, even though success isn't guaranteed. Chapter 33. The Artistic Response. While scientists look for other civilizations with telescopes and mathematicians, artists are exploring the same questions through different means. Science fiction has been imagining alien civilizations for over a century. Some of it is thoughtful and plausible. Some of it is wild speculation. But all of it serves a purpose. It helps us think through possibilities we can't yet test. Star Trek imagined a future where humanity has matured, joined a federation of planets, and explores the galaxy with curiosity rather than conquest. It's optimistic, maybe too optimistic, but it provides a vision worth aspiring to. The Three-Body Problem by Liu Cixin explores the dark forest hypothesis, that the universe is full of civilizations hiding from each other in terror. It's pessimistic, but it raises important questions about game theory and survival strategies. Contact by Carl Sagan explores what first contact might actually feel like, the mixture of wonder, fear, political complexity, and profound change. It treats the possibility seriously and respectfully. Arrival explores how communication with aliens might work and how it could change us. The idea that learning an alien language might change how you think is both scientifically interesting and emotionally powerful. These works and thousands of others serve an important function. They're thought experiments. They help us explore possibilities, test our assumptions, and imagine futures we can't yet reach. Visual artists have been depicting aliens for decades with varying degrees of plausibility. But even the implausible ones serve a purpose. They push our imagination beyond human-centered thinking. Musicians have explored cosmic themes, from Gustav Holst's The Planets to David Bowie's space-themed songs to contemporary electronic music inspired by cosmic scale and alien otherness. Art isn't separate from science in this domain. It's complementary. Science tells us what's possible. Art helps us imagine what it might mean. Part 10. The Ultimate Questions. Chapter 34. Are we ready? Here's a question we need to ask honestly. If we detected another civilization tomorrow, would we be ready? Technologically, probably yes. We could detect a signal, analyze it, and potentially decode it. We have the instruments and expertise. Scientifically, yes. We have people who've spent their careers thinking about this. We have protocols, even if they're not legally binding. We could mount a coordinated scientific response. Politically, this is where it gets dicey. Would nations cooperate or compete? Would there be a unified human response, or would it fragment along existing political lines? Imagine, we detect a signal. China wants to respond one way. The US wants to respond another way. Europe wants a third approach. Who decides? How? Culturally, how would different cultures react? Some religions might see it as confirmation of their beliefs. Others might see it as a threat to their worldview. How do we navigate these differences? Psychologically, this is maybe the biggest question. Would people panic? Would it cause existential crisis? Or would most people just incorporate it into their existing beliefs and move on with their lives? History suggests that humans are pretty good at normalizing the extraordinary. When we learned the Earth orbits the Sun, some people freaked out, but most adjusted. When we learned about evolution, some rejected it, but civilization continued. Contact with aliens would be bigger, but humans are adaptable. We'd probably handle it better than we fear, but worse than we hope. Ethically, are we prepared to make decisions that might affect not just our civilization, but theirs too? If we respond to a signal, we're making a choice on behalf of all humanity without asking everyone's permission. That's a huge ethical burden, and if our response somehow puts the other civilization at risk, if, for example, it draws the attention of something dangerous to them, we bear responsibility for that. Chapter 35. What if we're first? Here's a possibility we haven't fully explored. What if we're early? What if intelligence is rare enough and slow enough to develop that we're among the first civilizations in the universe? This would be a massive responsibility. If we're early, then our choices matter even more than we thought. We're not just deciding humanity's future. We're potentially setting the template for how civilizations behave. We are the elders, the first movers, the ones who establish the norms. If we colonize space, we set precedents. Do we terraform planets that have simple life, destroying it to make room for us? Or do we treat all life as sacred and expand only to dead worlds? Our answer to this question could become the galactic norm. Later civilizations might look at what we did and either follow our example or learn from our mistakes. If we develop AI, we're creating the first artificial minds. Will AI be slave, partner, or successor? How we answer this question might determine how consciousness evolves throughout the universe. If we encounter other life, we establish first contact protocols. Are we colonizers or colleagues? Conquerors or cooperators? The first contact between intelligent species might set the tone for all future contacts. If we survive and spread, we determine what survives. We'd be carrying Earth life to the stars, not just humans, but our microbes, our plants, our animals. We'd be seeding the galaxy with our version of biology. That's an incredible privilege and responsibility. We'd be shaping the future of life itself. Chapter 36, The Final Uncertainty. After all this speculation, analysis, and thought, we come back to the fundamental uncertainty. We don't know. We don't know if other civilizations exist. We don't know if we're alone or one of many. We don't know if the universe is full of life or if we're a cosmic accident. And here's the thing. We might never know. It's possible that the universe is so vast and civilizations are so rare or so brief that we'll never detect another one. We might search for centuries or millennia and find nothing. How do we live with that uncertainty? Option 1. Assume we're alone. Focus on Earth, on humanity, on preserving and improving what we have. Treat the search for other civilizations as interesting but not central to our purpose. The risk: we might become complacent, small-minded, missing opportunities to prepare for contact or to expand beyond Earth. Option 2. Assume we're not alone. Act as if other civilizations exist and we might encounter them. Prepare, search actively, think cosmically. The risk? We might spend resources on preparation for something that never happens. We might become so focused on hypotheticals that we neglect concrete problems. Option 3, hold both possibilities, accept that we don't know, and act wisely given that uncertainty. Prepare for contact while addressing earthly concerns. Search for others while valuing ourselves. This is probably the wisest approach, but it's also the hardest. Living with ambiguity, acting without certainty, hoping without knowing. These are difficult for human psychology. But maybe that's the test. Maybe the civilizations that survive are the ones that can handle uncertainty without becoming paralyzed or reckless. Part 11. What It All Means. Chapter 37. The Bigger Picture. Let's zoom out to the biggest possible perspective. The universe is 13.8 billion years old. It will exist for trillions of years more. During that time, countless stars will be born and die. Countless planets will form and dissolve. And somewhere in that vast expanse of space and time, consciousness emerged. Maybe it emerged once, here, on Earth. Maybe it emerged many times in many places. But either way, the universe went from being purely physical, just particles following rules, to being aware of itself, from unconscious to conscious. From dead matter to living thought. That's extraordinary. That's the most significant development in cosmic history. And if it happened multiple times, if there are other civilizations out there, that makes it even more significant. It means consciousness isn't a fluke. It's a natural consequence of the universe's structure. The universe tends toward awareness. What does this mean? Maybe it means the universe has purpose, not designed purpose, but emergent purpose. Through natural processes, it generates complexity, life, intelligence. Maybe consciousness is what the universe does, or maybe it means nothing. Maybe consciousness is just a temporary state of matter, no more significant than any other arrangement of atoms. We exist, we think, we disappear, and the universe continues. But here's what I think. Consciousness matters because it's the only thing that can assign meaning. Without consciousness, the universe is just events happening without significance. With consciousness, the universe becomes meaningful. Every civilization, human or alien, is the universe trying to understand itself. We're all doing the same thing, looking out at the cosmos and asking, what is this? What am I? What does it mean? If there are other civilizations, they're our colleagues in this endeavor. Different perspectives, different approaches, different insights, but the same fundamental project. Making sense of existence. Chapter 38, The Choice We Face. Ultimately, whether or not other civilizations exist, we face the same choice. We can be destructive or creative, selfish or cooperative, short-sighted or forward-thinking, tribal or universal. The universe doesn't care which we choose. Physics will continue regardless. But we care, or at least we should. If we're alone, then we're the only consciousness in the observable universe. That makes us incredibly precious. We have a responsibility to preserve consciousness, to explore, to create, to ensure that this cosmic accident of awareness continues. If we're not alone, then we're part of a larger community. We have a responsibility to be good neighbors, to contribute to the cosmic dialogue, to be the kind of civilization others would want to encounter. Either way, the choice is the same. Be better. Better at cooperation. Better at thinking long-term. Better at solving problems without destroying ourselves. Better at creating instead of destroying. Better at wondering instead of assuming. The existence of another civilization wouldn't save us. Even if they're out there, even if they're more advanced, even if they have solutions to our problems, we still have to do the work ourselves. We still have to survive our current challenges. We still have to earn our place as a mature civilization. But the possibility inspires us. Knowing that it might be possible, that other civilizations might exist and might have survived, gives us hope. It suggests that the problems we face are solvable, that the dangers we navigate are passable, that the future is possible. Chapter 39. What you can do. This might all seem very abstract. Cosmic civilizations, existential risks, timescales of millions of years. What does it have to do with you right now in your ordinary life? Actually, quite a lot. Think bigger. Your choices matter not just for yourself, but for the entire trajectory of human civilization. Every time you vote, you're influencing whether we survive. Every time you consume or conserve, you're affecting our planetary systems. Every time you create or destroy, you're shaping our culture. You're not just living your life, you're participating in humanity's story. And if humanity is part of a larger cosmic story, then your choices echo further than you think. Learn more. Educate yourself about the universe, about science, about the challenges we face. The more you understand, the better decisions you can make. You don't need to be a scientist. You just need to be curious. Read about climate change. Read about AI. Read about space exploration. Read about other cultures. Expand your perspective. Care about the future. Not just your future, but the distant future. What kind of civilization do you want humanity to become? What do you want us to be if we ever do meet another species? Make choices that consider long-term consequences. Support policies that invest in the future. Think beyond your lifetime. Stay curious about the cosmos. Look up at the stars sometimes. Wonder about what's out there. Remind yourself that you're part of something vast and mysterious and possibly very crowded. That sense of cosmic perspective, of being a small part of something incomprehensibly large, can be humbling in a good way. It can make petty concerns feel petty and important concerns feel more important. Be kind. If we ever do encounter another civilization, or if they're watching us right now, what would we want them to see? I'd want them to see a species that, despite its flaws, tries to be kind, that values compassion, creativity, and cooperation. That struggles but doesn't give up. That dreams of being better than it is. Be the kind of human you'd want aliens to meet. Conclusion: the question that matters. We started with a question: what if there's another civilization like ours? We've explored the mathematics, the science, the philosophy, the implications. We've thought about what they might be like, how we might find them, what it would mean. But here's the truth: we don't know if they exist. We might never know. And yet the question matters. It matters because asking it forces us to think beyond ourselves. It forces us to consider our place in the cosmos, our responsibilities to the future, our potential as a species. It matters because whether we're alone or not, we need to act as if our choices have cosmic significance, because they do. If we're alone, we're the only consciousness in the observable universe, and we have a duty to preserve and expand it. If we're not alone, we're part of a community of minds, and we have a duty to be worthy members of that community. Either way, we matter. What we do matters. How we treat each other matters. Whether we survive matters. Somewhere in the universe, right now, there might be another being asking the same questions we're asking, looking at their stars, wondering if they're alone, hoping they're not. We can't answer their question for them. We can't even answer it for ourselves, not yet. But we can live as if the answer matters. We can build a civilization worth finding. We can become a species worth knowing. We can ensure that if someone is looking for us, when they find us, they find something worth the search. That's not just about aliens. That's about us. Who we are, who we want to be, and what we want to leave behind. The universe is vast and ancient and possibly teeming with life. Or it's empty and silent, and we're the only ones asking questions. But in the end, the same truth applies. We're here. We're conscious. We're capable of wonder, creativity, kindness, and hope. That's extraordinary. That's precious. And whether we're alone or surrounded by others, that's worth protecting, worth celebrating, worth striving to be worthy of. So look up at the stars tonight. Wonder about what's out there. Feel small in the best possible way, part of something so much larger than yourself. And then come back to Earth and do the work of being human, of being kind, creative, curious, and compassionate. Because that's what civilizations are made of. That's what survives. That's what matters. Not the monuments we build or the technology we develop, but the consciousness we preserve and the kindness we show along the way. If another civilization is out there, I hope they're doing the same thing. And if they're not out there, I hope we become the kind of civilization that future beings, whether our descendants or someone else's, will be glad existed. The universe is waiting. The question is open. What kind of answer will we be?